Welcome, ladies and gentlemen, to this video lecture. So now we will look at what is called finite limits at infinity. So before we give the definition, let's just think about what this means. So for example, if you have some value L and you've got a function that tends to L as x gets, or the input gets larger and larger and larger. So the idea here is for any epsilon, if you look at this interval centered at L of radius epsilon, you should be able to find some point so that beyond that point the function values all lie within this epsilon strip. So that is the idea. Okay, let us write down the rigorous definition. So if we have some function defined on an open interval from a to plus infinity, then the following means. So the limit as x tends to plus infinity of f of x is equal to L, where L is of course some real number. This means the following. So it means for every epsilon greater than 0, there exists an m, capital M, greater than 0, so that if x is bigger than m, then the function values are within an epsilon distance of L. Okay. And of course you have a corresponding definition for limits at minus infinity. So if you have a function defined on an interval going to minus infinity, then the limit as x tends to minus infinity of g of x is equal to L. This means, what does this mean? This means for every epsilon greater than 0, there exists a delta greater than 0, so that if, no, not delta, there exists an n less than 0, so that if x is less than n, then f of x, all the function values are within an epsilon distance of L. So if you think about this, if we've got L over there, we have some function g that tends to L as x tends to minus infinity. What this says is if you take any epsilon and if you look at the interval of radius epsilon around L, you should be able to find some n so that to the left of n all the function values lie within this strip. Okay, so that is the idea. And of course, as before, we can show that we can transform limits tending to minus infinity to limits tending to plus infinity. So this is in effect reflecting around the y-axis. So if you have some function defined on an interval from minus infinity to a, the following are equivalent. following are equivalent. So the limit as x tends to minus infinity of f of x is equal to L, where L is of course some real number. This is equivalent to saying the limit as x tends to plus infinity of f of minus x is equal to L. And this is has the effect of, let's say you're looking at a function that tends to L as x tends to minus infinity. If you reflect everything around the y-axis, then of course the reflected function will tend to L as well as x tends to plus infinity. So that is the idea. Okay, I will see you in the next one, where we will do an example.